Hello and welcome. In this video we will walk through some of the elements that were discussed in the video of probability, distribution, sampling and hypothesis testing. Let us start with distribution. If you remember, we discussed about a binomial distribution in which we mentioned that whenever there is a yes-no aspect involved, we use a binomial distribution. And I had also mentioned that these are the distributions for which formulas of certain parameters are already established. So if we know some information about the distribution, we can already arrive or perform some calculations, for example calculating probability, etc. We'll see one of the examples over here. So let's say the question here is, if you have a website and you know that 1 in 5 people spend more than 30 seconds in your website. 1 in 5 people spend more than 30 seconds. Now the question is, if you pick random 10 of these people, what is the probability that 2 of them have spent more than 30 seconds? You want to understand this. If you want to understand this, so we start with, first of all, probability of someone spending 30 seconds, which is given by 1 in every 5. So it becomes 1 by 5. Then we mention the size. Size means, here if you want to pick 10 people, we will write here 10. We want to select 10 people, 10 random people, so we define the size 10. And out of 10, what is the question? Out of 10, we want to see if two of them have spent more than 30 seconds. So the value here is 2. Let's say V is 2. To find out this probability, there's a very straightforward formula, D and then the name of the distribution, binom, D binom, and then we just give the parameters and run it, and the result is 0.3. Now suppose the question had been not like what is the probability that 2 of them have spent more than 30 seconds, or rather what is the probability that number of people spending more than 30 seconds is less than or equal to 3. If had that been the question, then this is how we would have solved it. So we want to know the probabilities of, if it is less than or equal to 3. If it is less than or equal to 3, we want to know the probability of 0. So that means out of these 10 people, none of them would have spent 30 seconds, their probability, or 1, that is out of these 10 people, 1 has spent more than 30 seconds, that probability, or number of people is here 2. So if it's less than or equal, then we also add, if it is less than or equal, then we also add 3 here, and this becomes our new value. And then when we run this function, so similar function, we just have a range of values from 0 to 3. We see that there are 1, 2, 3, 4 probabilities, and to find out the final probability, we just add them up, and when we add them up, it becomes 0.87. So the probability that less than or equal to 3 people have spent more than 30 seconds out of these 10 people, it is 87%. Similarly, in a certain case, or if you want to know what is the value in 25th percentile in the distribution, so you just assign the value to a value of 0.25 and then run P binom, and when you run P binom, the 25th percentile in this particular distribution, the value is 0.10. Sometimes you may want to simulate a distribution, simulate a binomial distribution in this case. How do you do that? So in order to do that, we will simulate the values from the question itself. So it says you pick 10 random people, and we add the value 10 here, and out of that we want to check if two of them have had a favorable outcome in our case. So this is 2, where the probability of that outcome in general is 1 by 5, that is 20%. So we run this one and we see that okay, in the first simulation it is. So if we pick up, if we run this, we see that 4 of them have spent more than 30 seconds. In the second trial, 3 of them have spent more than 30 seconds. We can try again and we see 4, 2, 2, 3, 1, 2, 1, 0, and so on. So this is how you simulate. Now for other type of functions, we have similar formulas or similar functions. So just like d binom, we have, let's say, d Poisson, and we also have d norm. We'll see the examples just below. So the structure is same. It starts with d, and in case of binomial it becomes binom, in case of Poisson it becomes Poisson, in case of normal it becomes norm. So from the example that we had, from the question we had in the video, what is the probability that in one day 5 sales will be executed, and we are assuming that the mean sales per day is 4. So we have a very straightforward application here. We want to understand if within the period 5, what is the probability that 5 sales will be executed, where the mean within that period, mean per day, mean within this period is 4. So you just run this and the answer is here we go, 0.15. Now had the question been that what is the probability that the number of sales will be up to 5, let's say up to 5, so in that case up to 5, so we are taking this value again 0 to 5, so because we want to understand the probability of 0 sales and then add up the probability of 1, 2, 3, 4, 5, and so we just, like the previous one, if we run only this portion, this selection, we'll get 1, 2, 3, 4, 5 probabilities, and if we add those up we get the final probability. It's a good time to show the pipe operator in action over here. In case you do not remember, pipe operator was discussed in one of our previous videos. So if we want to use pipe operator here, what we do is we start with the data. So data here is 0 to 5. So we want to calculate the probability of 0 to 5 sales happening and then add them up. So we start with this. So let me select this and run to show what it is, 0, 1, 2, 3, 4, 5, and then we pass this value as the first parameter in the function here. So we pass this value as the first parameter in function here. If we run this, we see that we have 1, 2, 3, 4, 5, 6 probabilities, and then we just then this outcome will be passed on as the first parameter in the next function, which is sum. So if we run this, we have 0.78. So similar to R binom, we have R Poisson, where we provide the parameters, and if we run it, we see 1, 2, 3, 4, 5 simulations, and these are the results. Where the average of the given period is 4. Coming now to normal distribution. Just like d binom, we had d Poisson here. Similarly, we have d norm, and here if we want to understand the probability of a randomly selected person spending more than 50 seconds, given the mean is 45 seconds and the standard deviation is 10. So let us say first we want to understand if spend number if the person is actually spending equal to 50 seconds. What is the probability that if we randomly select a person, the probability, what is the probability of him spending exactly 50 seconds, and that becomes 0.03. Now we want to calculate, let's say more than 50 seconds. Remember, it is not less than, it is more than. So if we want to calculate the probability of more than 50 seconds, how can we do that? Because if you think about it, more than 50 seconds can be 50 up to infinity. How can we add that up? This is where one of the probability rules comes into picture. So what we do is we first calculate the probability of 0 to 50. So that is less than equal to 50, which is 0.7. And if you remember from the collectively exhaustive events, the summation of all possible events becomes 1. So if we subtract 1 minus this, then we get the probability that this person spending more than 50 seconds, given the mean is 45 and the standard deviation is 10. Now, if you remember, we had shown an example of where we had selected samples from a population and we had some sample parameters. And what if we want to estimate the parameters of the population from the sample parameters? This is how we do it. For example, the sample size is 25 and the sample mean is 300. Some parameter, let's say. The sample standard deviation is 18.5. Then what we do is we find something we call a, let's call a margin using a QT function. Here we provide a particular value. So let's say you want to calculate the confidence interval of 95%. If you want to calculate the confidence interval of 95%, you take this. Why do you take this? Let me try to show you here. Okay, we'll plot. And now let's say we want to add. So when we talk about 95% confidence interval, what we mean, AB line, let's say V equal to minus 3.75 and AB line V equal to 3.75. So you see the two lines shown here on the curve. So the area or the range between these is 95%. So that means the area beyond the range of these two will add up to 5%, because our confidence interval is 95%. So out of 100%, 5% is left. That 5% is divided into the two sides of the plot, which are beyond the boundary of these two lines, beyond the boundary of the two lines in this plot. So if we, since 5% is left, 5% will be divided into two sides of this plot. One side is 2.75, 2.5, the other is 2.5, and if you subtract that from 1, we get the 97.5. So we calculate the margin from here, and then if we want to find out what is the lower limit of the population mean. So if the sample mean is 300, we cannot exactly calculate what is the population mean, but we can give a range that okay, the population mean will be between so and so. So the lower limit of that particular range is calculated like this by S, the sample mean minus the margin that we calculated, and the upper limit is calculated as sample mean plus the margin that we had calculated, and it comes out to be somewhere between 292 and 307. So you can be 95% confident that if the sample mean of a certain parameter is 300 with a sample standard deviation of 18.5 with a standard size of 25, sample size of 25, you can be 95% confident that the population mean will be somewhere between 292 and 307. Similarly, let's say we want to compare the means of two. So let's say we want to compare the means of two, then we use this formula. I mean, these are mathematical formulas, you don't need to worry about. I am giving you the code, just use it. Again, we calculate the margins, and here since we are comparing two, since we are comparing two, we want to see if what is the difference in the means. So we can run these to check that you can be 95% confidence that the difference in means of these two will be somewhere between -3 and 23, somewhere between -3 and 23, with again 95% confidence interval. Okay, now let us talk about proportion. So just like we had means and difference of means, we can do it the same with proportion. Let's say the sample size is 100 and the proportion of certain item in that, or certain thing in that particular sample, is 0.56. Again, we calculate the margin and we get a lower limit of the population proportion, which is 0.46, and also upper limit of 0.65. Just like we calculated the difference of means, we can calculate the difference of proportions like this, and we can find the result like this. Alright, now let us come to hypothesis testing. Okay, let us say we have a sample where we have certain values as shown here, and we allot it to variable x. Now if we want to understand if the population mean is, let's say, 45, our question is we want to understand if the population mean is 45. So what is the null hypothesis? Now null hypothesis will be mean equal to 45, and the alternative hypothesis will be mean not equal to 45. Now to test this, we will test the null hypothesis. There is a function called t.test. So in this we first provide this parameter, the value of the samples, and then we provide the mean that we want to check. So we want to check if the mean is 45, so we are giving 45. Now if you remember, since this is an equality question, we want to find out if the population mean is equal to 45, then we have to use two-sided test. We are using two-sided test with a confidence interval of 0.95, and if we run this, the result is this. So how to read this? You can be 95% confident that the mean is between 35.75 and 47.24. That means the mean is actually in between 45. Another way to check this is checking the p-value. As long as the p-value is not less than or equal to 0.05, you will not reject the null hypothesis. Let me repeat, as long as the p-value is not less than or equal to 0.05, you will not reject the null hypothesis. And since in this case it is 0.2, which is much larger than 0.05, we will not reject the null hypothesis. And the null hypothesis was that the population mean is 45. This is also reflected. We will not reject that because the p-value is not less than or equal to 0.05. And we also have a confirmation here where it says there is 95% confidence that the population mean is between 35.75 and 47.24 from the data from available in this sample. Now suppose you want to know or want to test if the population mean is less than 45. To do that, you just again run the t-test with the same parameters. However, in this case you write, instead of two-sided, you write less, and if you run it, you see that if you see that again p-value you cannot reject. Greater than or equal to 45 is the null hypothesis. Since p-value is less than not less than 0.05, you cannot reject the null hypothesis, which is the population mean is greater than or equal to 46 and 45. It is true. It's marginally true because it says there is 95% confidence interval that is between minus infinity to 46. So you cannot conclusively say that true mean is less than 45. So the alternative hypothesis is also written here, true mean is less than 45. However, since the p-value is not less than or equal to 0.05, we did not reject the null hypothesis, and hence alternative hypothesis does not hold. Similarly, if we talk about finding out if the population mean is greater than 45, we use an alternative equals to greater. And what will be the null hypothesis here? I won't tell it. Try to write it in the comments. And here we go. Again, we cannot reject the null hypothesis based on this. We cannot reject the null hypothesis based on the values from this sample. Now let us try to do with two samples. So where we want to compare if the means are actually different or same. Here the null hypothesis is that the mean of the population from these samples. So this is one sample, this is another sample. This will have a population and this will have a population. We want to find out if the means of those populations are equal or not. So to do that, we run this test, and this is the result. We run this test, and this is the result, which says, well, there is 95% confidence that the difference in mean is between minus 1.5 to 17.5. So 0 actually falls in between these range. So again, we cannot reject the null hypothesis, and if that is reflected again in p-value, which is 0.09, much larger, or at least larger than 0.05, so we cannot reject the null hypothesis, which says that the difference in mean of these two is 0. Difference in mean of these two is 0. So just like t-test, we can also do a prop test. To do that, I will not be showing that in the video. You can just run a question mark and prop test and read the function description from the help section and try to do that yourself. Please let me know in your comments if you could do it, or what were the, if you want to share some of the results that you saw. And of course, if you have any confusions, you can always get back to me. reach out to me, or you can write your queries in the comments as well, not a problem. So this finishes our video for today. I hope this was fruitful and you enjoyed it. Again, I will appreciate any feedback that you have. I would really appreciate if you could kindly show your support by sharing, subscribing, and liking. Thank you very much.